this is section 5.4. Our objectives for today are the student will be able to solve equations containing radicals and rational exponents, and then to solve radical inequalities. So there's not a lot of steps to take you through today or notes, but we're going to go through a lot of examples. So, our core concept. The book has these. I've written them a little bit differently, but steps to solve radical equations. First of all, you want to isolate the radical if possible. So that means get that radical by itself, and you'll see as we go through some problems. Then you raise each side of the equation to the power of the index to obtain a polynomial equation. So this is just if I've got the square root, or let's say the cube root of something, whatever these quantities are, then to get rid of that, I'm going to take this to the third power and that to the third power, because those will cancel out, and then I'll solve what's left. So you'll see again as we go through those, and then you simply solve the resulting equation. So, to look at some examples. So, here's our radical right here, so we have to get that by itself, so I would divide by 2. And we get the square root of x plus 1 equals 2. Then it's the square root, so we square both sides. And we get x plus 1, because those cancel, equals 4. And then we solve for x, subtract 1, and we get x equals 3. You should always check these, because we're going to get some extraneous solutions as we go through this where the numbers don't actually check. But 3 plus 1 is 4, the square root of 4 is 2, 2 times 2 is 4, and so it checks. This next one, we've got the cube root. And so in this case, the radical already isn't by itself yet. We've got to get rid of that minus 1, so we add 1 to both sides. And now we get the cube root of 2x minus 9 equals 3. Then to get rid of the cube root, we cube both sides. So we get 2x minus 9 equals 27. And then it's a simple algebra problem. Add 9, 2x equals 36, divide by 2, so x equals 18. And then we check it. 36 minus 9 is 27, and the cube root of 27 is 3. You won't get extraneous solutions with this because we don't do a plus or minus, which you can do when you're doing square roots. So you can go ahead and try these 3, and then come back and check and see how you did on that. And I'll go through them. So on this, again, box that radical. Add 9 to both sides. So we get the cube root of x equals 3. Then we're going to cube both sides. So we get x equals 27. We can check it. Cube root of 27 is 3. 3 minus 9 is negative 6. So it checks. Now here's one where you can't get the radical by itself, because there's a radical on both sides. So when we have this, we just have to square both sides. Makes it fairly easy. There get some more complicated ones later. But these squareds cancel, so we get 2x plus 5 equals x plus 7. And then I'm going to subtract the x and move the 5 to the other side. And so we get x equals 2. Check it. 2 times 2 is 4 plus 5 is 9, so the square root of 9 is 3. 2 plus 7 is 9, the square root of 9 is 3, so we're done. Go to the third one. Radical by itself, so we divide by 2. And so we get the cube root of x minus 3 equals 2. Cube both sides. X minus 3 equals 8. Add 3, x equals 11. So let's check it. 11 minus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. So we know that we have them right. So those are some of the fairly easier ones to do. Here's where they can get a little bit more difficult. When you have a situation like this, we've got the radical by itself. Okay, so we can just square both sides. But here's where people remember, I have to square this whole side. And you can't just square both terms. Remember, x plus 1 squared means to take x plus 1 times x plus 1. And if you FOIL that, you get x squared plus 2x plus 1 equals 7x plus 15. So now a lot more work to do when we go to solve this. It's a quadratic, so to solve a quadratic, you set it equal to 0. So I'm going to move everything to that side. And so I get x squared minus 5x minus 14. So now you're going to have to factor this. I'm going to go ahead and just do this quickly. X minus 7, x plus 2. And so I get two answers. I get 7 and I get negative 2. But if I plug in these numbers and check it, 7 plus 7 is, or 7 times 7 is 49, plus 15 would be 64, and the square root of 64 is 8, and 7 plus 1 is 8. That checks. But when I plug in negative 2, this is where I have the issue that comes in. When I plug in negative 2, over on this side I get negative 1. And remember, square roots cannot give you negative numbers. And so that is what we call an extraneous solution, in that it worked when we did the problem, but not when we go back and check it. So those are ones you have to be careful of. Another one that gets tricky is this. So be careful on this one. Again, we can't isolate the radical by itself. So what we're going to have to do is square this side, so I have to put that whole thing in parentheses and square it. So the right side's easy, that just cancels and it's 3 minus x. But the left side, I have to go the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. So when I multiply this, square root of x plus 2 times the square root of x plus 2, it's the same thing, so the square roots cancel, so I get x plus 2. But that's just from here. Now I have to go that times 1, which would be plus x plus the square root of 2. And then I get another one plus x plus the square root of 2. And then finally, I get 1 plus times 1 is 1. So on this side, I'm going to end up with, I have x, and I have plus 3, plus, now remember, if what's inside the radical is the same, you add the numbers in front. So 1 plus 1 would be 2 square root of x plus 2. So you can see, even though I've squared that, I still have a square root inside there that I have to get rid of. So now we have to go back and we have to isolate this part. So now I'm going to go back and I got to get this by itself. So I'm going to, first of all, subtract x and subtract 3. So on this side now, I'm going to go down here, I get 2 square root of x plus 2 equals negative 2x, because the 3 and negative 3 cancel. Now I still have to get this by itself, so I divide by 2, and I get the square root of x plus 2 equals x, excuse me, negative x. Then I square both sides, and so I get x plus 2 equals x squared. It's a quadratic, so we set it equal to 0. I'm going to subtract x and subtract 2. So I get 0 equals x squared minus x minus 2. That factors into x minus 2, x plus 1. And so we get 2 and negative 1. If we go back and check it now, so I have to go back up here to the original, and I'm plugging in, our answers are 2 and negative 1. Well, if I plug in 2, I get 2 plus 2 is 4, and the square root of 4 is 2, and 2 plus 1 is 3. So I got 3 when I plugged in 2 on that side. And when I plug in 2 on this side, I get 3 minus 2 is 1, and the square root of 1 is 1, so that does not work. So that answer didn't work. So now let's try negative 1. Negative 1 plus 2 is 1, and the square root of 1 is 1, and 1 plus 1 is 2. And if I plug in negative 1 here, I get 3 minus a negative 1, which is 4, and the square root of 4 is 2, so that does check. And so my answer that works is -1. So you can see, there's a lot of work to do. You just have to be careful as you go through and do those to make sure that you don't make any mistakes. So let's have you do these three, pause the video, do the work, come back and check to see how you did. So, if you've done this right, it's already isolated. So we square both sides. So we get 10x plus 9. Now I'm going to assume that you can go x plus 3 times x plus 3, but you would get x squared plus 6x plus 9. Or you should have. I'm going to now, it's quadratic, set it equal to 0. And so I get 0 equals x squared minus 4x. And that would just, the 9's would cancel. And so this factors into x times x minus 4. And so that means my answers are either 0 or 4. If I plug in 0, I get 0 plus 9 is 9, the square root of 9 is 3, 0 plus 3 is 3, so that checks. So 0 is alright. If I plug in 9, I get, or 4, I get 40, plus 9 is 49, and the square root of 49 is 7, and 4 plus 3 is 7. So in this case, they both work. There's no extraneous solutions. So I'm good on that one. The second one, a little bit easier. Because they're both in the radical signs, I can just square both sides. And I get 2x plus 5 equals x plus 7. Subtract x, move the 5 to the left, or to the right. And we get x equals 2. Again, they're real easy to check. 2 times 2 is 4 plus 5 is 9. The square root of 9 is 3. 2 plus 7 is 9. So we get the same thing. So that works. And then this last one, again, this is where they get more difficult. Because I have to square this. On this side, it's easy. We just get x minus 2. But on this side, I have to take the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. And so the square root of x plus 6 times the square root of x plus 6 is just x plus 6. And then I'm going to get 2x plus 6 and another 2x plus 6, so it gives me 4 square root of x plus 6. And then 2 times 2 is 4. So now if we simplify this side, we get x plus 10 plus 4, x plus 6 equals x minus 2. I'm going to go ahead and subtract x and minus 10. And we get 4 square root of x plus 6. Now in this case, the x's cancel, so we get negative 12. Let's divide by 4. And we get x plus 6 equals negative 3. Excuse me, that should be in the square root. Now here's where you can stop, because the square root is not going to give us a negative number when we're solving the equations. So we can just stop there and say there's no solutions on this one. If you went ahead and did this, squared both sides, this is where you get into the trouble, because it becomes a positive 9 now, so we get x equals 3. But if you check it, 3 plus, or wait, are we okay? Maybe we are okay. 3 plus 6 is 9, the square root of 9 is 3, 3 minus 2 is 1, so we're okay. And 3 minus 2 is 1, no. So we're okay on that, it does work. So you're going to have to go through and check those. Be careful on it. It's because we're squaring it, we get rid of that negative sign, and we're okay. And I guess because we can do the square roots plus or minus, so it worked out. Now, the other thing that you have to do on this is we're going to have 2x to the 3/4 where we have fractions in our exponents on these. You can take care of it the same way. I mean, we could write this as the 4th root of 2x to the 3rd and then to the 4th power to each side. But an easier way to do it is just get this by itself, so we subtract 2, and so we get 2x to the 3/4 equals 8. And then what you do to get rid of this 3/4 power is you do the reciprocal power, 4/3. Because the 3's cancel, the 4's cancel, so we get 2x. And then we're doing 8 to the 4/3. Now you can do this on the calculator, or remember, this is the same thing as writing it this way. The cube root of 8 is 2, and 2 to the 4th is 16. Divide by 2, and you get x equals 8. Check it, that would be 16. The 4th root of 16 is 2, 2 to the 3rd is 8, plus 2 is 10, and it checks. If we look at the second one, so again, because it's a fractional exponent, we just do the reciprocal, we square both sides. Because remember, 1/2 power means the square root, so it becomes x plus 30 equals x squared. It's a quadratic. Let's set it equal to 0. So we get x minus 6, x plus 5, and so our answers are either 6 or -5, and if you check it, this would be, plug in 6, that would be 36, the square root of 36 is 6, which is 6, so that checks. But if I plug in -5, I get 25, and the square root of 25 is 5, not -5. And so this would be an extraneous solution, it would just be 6. So, same thing, pause the video, come back and try these. So if you did this right, it's 1/3 power, so you would cube both sides, so you get 3x equals -27, divided by 3, x equals -9. If you check that, that would be 3 times -9 is -27, the cube root of -27 is -3. This side we would square both sides, so x plus 6 equals x squared. Quadratic, set it equal to 0. Subtract the x and subtract the 6, and that factored into x minus 3, x plus 2. Check it, it would be 3 or -2. Plug them in, 3 plus 6 is 9, the square root of 9 is 3, so we get that. Plug in -2, you get 4, the square root of 4 is 2, not -2, so that would be an extraneous solution. A little bit more difficult, 3/4, but again, you just do 4/3. And so that would be x plus 2 equals, the cube root of 8 is 2, 2 to the 4th is 16. Subtract 2, x equals 14. And we're done. So hopefully you got those right, and they checked for you. If we go to this one, now we're going to do inequalities. Inequalities aren't that much more difficult. You're going to do it the exact same way. You just have a restriction, especially when it's a less than or equal to. Because remember, we can't take the square root of negative numbers. So this would be, we know that the square root, this x minus 1 has to be greater than or equal to 0. So we know x has to be greater than or equal to 1. So that's a restriction we have in this problem. So we'll try it in the problem. Now we'll solve this. So divide by 3. Square root of x minus 1 is less than or equal to 4. Square both sides. X minus 1 is less than or equal to 16. Add 1. So we got x is less than or equal to 17, but we also know that x has to be greater than or equal to 1. So that would just mean x is between 1 and 17. You don't have to worry about that if it's greater than, because it would have been x is greater than 17, then this wouldn't even apply. So let's have you try these two. Again, pause the video, then come back and check, see how you did. So if you did this right, you should have divided by 2 first to isolate that. Then we would square both sides. Now remember, you have to square the whole thing, so you should have gotten x minus 3 is greater than or equal to 9/4. And then you would add 3. So this is 2.25. So x is greater than or equal to 5.25. We also know that, because remember this has to be greater than or equal to 0. X has to be greater than or equal to 3. But it's already greater than or equal to 5.2, so we can just leave it that way. With cube roots, you don't have to worry about the restrictions, because remember, we can do cube roots of negative numbers, so we don't have to worry about it on this one. We just solve it. Divide by 4. Cube root of x plus 1 is less than 2. Cube both sides. X plus 1 is less than 8. Subtract 1, x is less than 7. And that would be our answer. So, on the assignment, it'll be on the computer. It's page 266, numbers 3 to 43, the odds. But I want you to skip 19, 33, and 35 if you're doing it on the book. If you're on the computer, they've already been taken out and you don't need to worry about that. So, good luck with that.